Welcome, this is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium. This conference would not have been possible without our sponsors, PQ Shield, SSL.com, Entrust, Keyfactor, HID Global, and the organizational support of the Post-Quantum Cryptography Working Group of the PKI Consortium, and in particular, Entrust, Keyfactor, and Logius. Would you like to join the PKI Consortium? Go to pkic.org/join, or contact us if you would like to become a sponsor.
Our next speaker actually wasn't originally slated to talk today. In fact, I think he found out about the presentation last night at dinner. So kudos to you, Roman, for being a sport about this.
Thank you, Chris. My name is Roman Cinkais. I'm from 3K company, where we are focused on building open source tools for encryption management, PKI, but also payment card industry security. I'm also trying to push and drive the PKI maturity model, which we are building as part of the PKI consortium. So if you haven't tried it yet, I would really encourage you to do this. And before we will see the slides, I can tell you my experience with CBOM from last couple of days when I was traveling to Austin, and I was really trying to prepare the presentation on the last minute. So you shouldn't be speaking loudly about the CBOM on public, and especially on the airport. People tend to be really nervous when they will hear something about the CBOM because they don't understand we are talking about cryptography as you are. So be careful when you are speaking about the CBOM. Okay. So let's speak about the CBOM, not CBOM, and if it is enough. And I will not tell you for what enough, because I think you will figure out during the presentation. You can make your own opinion. Yeah. So while we will see the next slide, I will be speaking at the beginning about the urgency of transitioning the classical cryptography to post-quantum. Yeah, here it is. Maybe you know this quadrant. It basically tells us where is the highest impact, where is the highest risk of quantum threat for the companies. On the one axis, you see the data shelf life, and on the second, system life cycle. So naturally, as we would expect, the insurances or banks are the most exposed in that sense. However, we are usually speaking about the problem of harvest now, decrypt later, which is connected to the transition to PQC. But from my perspective, this is something that will not go away simply when we will do the complete transition to the PQC, because it may happen again. Yeah? We can collect the data in a real time and wait if some algorithm will be broken later, and then we can simply do this again. So from my perspective, when we would like to talk about the transition, we should focus on inventory, we should focus on the cryptographic agility, and especially with the rise of the AI, when no one is talking about it, but the AI would be able to do some crypto analysis, also on the PQC algorithms. So it may really happened quickly that some of the algorithms that we currently see as good and secure may be broken or deprecated in the near future. And the cryptographic agility, whatever it is, whatever it will look like eventually, would be, from my perspective, something very, very useful to avoid risk of having deprecated algorithms in place for a long time. I will focus during my presentation, because I will be speaking about the CBOM on inventory, of course. And we will speak about how to make some transition of legacy systems. What does it take, or how it can look like, and what should be next. That's also related to CBOM, as you will see. Speaking about that, is it working, Sven? Yeah. So we are talking about bill of materials, and bill of material as a BOM is by the definition structured data that can be understood by machine, and the primary focus is to give you a good insight into the inventory of your components, which can be the software, which can be a cryptographic asset, which can be eventually anything that we will need to inventorize in some good standardized way. So initially, the bill of materials were designed to improve the transparency because of the various supply chain attacks. And currently, we have two primary formats, which is SPDX and CycloneDX. And during this presentation, I will focus only on the CycloneDX. When we are speaking about the bill of materials, we need to start from the SBOM, which was the initial bill of materials that was designed to provide transparency in the supply chain of the software. That's SBOM, like a software bill of material. And the CycloneDX is a full stack standard that defines bill of materials in the various situation you might be. And it was initially published as ECMA International, as you can see, 424 number, and currently is under umbrella of the OWASP Foundation and the ECMA International Technical Committee for Software and System Transparency. There is a definition of various types of bill of materials, which I'm not going to speak about all of them. We will focus on the CBOM and the SBOM as the initial definition. Yeah, it's a delay. So I'm sure that all of you know the SBOM, because it's for a few years with us. The big driver for creating the SBOM was the executive order number 14028. But now we also have a different other regulations and standards also in Europe, NIS2 or DORA, which is about the operational resilience. And all of them mandates that we should take care about the supply chain, and we should be able to understand what parts of our software is inside and how it is dependent on, for example, on some libraries. This was the initial work to create the SBOM, and then the SBOM was extended with another components for the cryptographic asset, which can include keys, algorithms, protocols, certificates, and maybe other assets if we would like to define them. The basic structure of the SBOM is on the picture on the right side. There was a basic definition or the minimum requirements what the SBOM should contain. However, the Cyclone-DX format is going beyond that and defines some additional attributes, additional components that can be included in the SBOM to cover all the dependencies, vulnerabilities, or some custom definitions that you might have. So the SBOM is really the basic where the CBOM is included. And we know what was the adoption of the SBOM. I'm talking about that because the SBOM is here for basically 3 to 4 years, and it was not adopted immediately. So according to the Linux Foundation report from the 2022, as you can see here, the adoption was basically 3 years. And after that, we can say that the SBOM was adopted. It can be used across the companies for the communication of the dependencies and to create a higher transparency in the supply chain. The CBOM was introduced only recently. Basically, it was standardized 6 months back in the Cyclone-DX version 1.6. There was actually a lot of work provided by IBM before it was standardized as part of the Cyclone-DX. And the primary focus of the CBOM is to create a structured inventory that can be understood by machines and will contain all the cryptographic material, which can eventually provide the transparency and reduce the risk of having something that is deprecated, because we can manage it through the CBOM. And the idea of using the CBOM is to manage the inventory, which is one of the crucial prerequisites for effective transition to PQC. If you don't have inventory, you don't know what you have inside your infrastructure, you are not aware of it, you cannot migrate it simply, right? Let's take a closer look on the CBOM structure. On the right side, it's the typical components of the bill of materials defined by the Cyclone-DX. And on the left side, you can see the component which can include the cryptographic asset and other crypto properties that are dependent on type of the cryptographic asset we are working on: protocol, key, certificate, or algorithm. And as you can see, it can contain various data, which includes also services where we are using the cryptographic assets, vulnerabilities, if there are any. It can contain annotations, definitions, and also extensions I will be talking about. To be more precise, so an example of the CBOM algorithm, which is described according to the Cyclone-DX format. Well, it is worth to mention that I'm presenting the JSON format, which is easily or more easier readable by the humans. But the CBOM can be represented also in different formats. If you prefer XML or something else, it can be done, of course. I will use throughout my presentation the JSON format. So this is an example of the CBOM algorithm, the Lithium 5. And as you can see here, the structure looks with the crypto properties for the algorithm, crypto functions, including the OID, which defines the algorithm that you will include in the inventory. And then you can use the algorithm to be referenced by some other cryptographic materials like the keys, for example, or protocol, which will be also shown on the next slide. Okay. Okay, so the CBOM certificate, for example. You see the asset type is a certificate in that case, and we have different properties like subject name, issuer name, validity of the certificate, and we have references for the signature algorithm or subject public key. And these references are basically a placeholders inside the CBOM where you can find the definition of that algorithm. Yeah? So you can, for example, define the set of algorithms you are using, and then you are simply referring from the CBOM on the algorithms you are using in certificates or in protocols or in keys. Now, this is a basic structure of the CBOM, which can be included in the SBOM. And there are various ways how it can be done, defined by the so-called BOM link, which has a predefined format. As you can see on that slide, it can be referenced from the SBOM, or you can use the external reference point where you will define the URL where you can find the CBOM. So you can then combine the information in the SBOMs, CBOMs, or other locations where you would like to have it to create a complete picture of the inventory for some specific application or for some specific component you are working with. The extensibility is included as part of the CBOM. So simply said, there are key value pairs that you can use for extending the information. For example, typically the certificate cryptographic asset does not contain the data about the certificate. If you want to include it, you can use the extension. You can include, for example, the certificate, encode it, and put it into the CBOM, so you can also have additional information, maybe that you can then use for your inventory purposes. But having that said, what we are looking for is to use the CBOM to get a comprehensive inventory where we can collect all the information and we can create an overview. We can also do some analysis on top of that. So we are looking to build the inventory that contains all of the cryptographic assets defined. And we would like to have only one. We would like to really put it all together. And for that purpose, we are talking about building inventory. And the first point is to make a visibility, to create a visibility through the discovery, where we need to, of course, know all the sources where we are looking for some cryptography or CBOMs. In the second step, we can include some extensions or some metadata into our inventory. And in the third step, we can start planning, we can start prioritizing the transition to the PQC. For having the visibility, we need to run the discovery. And when you are implementing the CBOM, you will end up in the situation where you have multiple CBOMs from different applications. It can be also from the same application, but from a different version. So you need to handle it somehow. You need to merge it somehow to be able to create the overall picture of all the cryptographic assets you have in the inventory. And I'm talking about also the protocols, algorithms, and so on. because if you are working with some inventory tools currently, they might work only with certificates, for example. But all of that cryptographic assets are important part of the inventory. So you need to know where to find it, you need to know how to merge it. And this is not provided by the CBOM, so you will need some additional tool that will have a logic how to combine it together, how to merge it. So you would like to consolidate the inventory, and then you would like to automate the discovery process. It's a difference when you get a CBOM from an application that was statically generated from the code. It's different results on the CBOM when you have application in the operational state that will generate some key, for example. And you might get also a different results when you work with the same cryptographic assets from different applications, and you need to handle that. Yeah, so this is not provided by the CBOM. You will need to put some logic behind that. What is good to adopt is telemetry. I have a good experience with open telemetry, which can provide you with some additional insights, especially when you are working with some legacy systems, and collect some information about the cryptography. Then what you would like to do with the inventory is to manage the inventory. So you would like to manage to become the cryptographically agile. You would like to put in place some compliance rules. You would like to mitigate the risk. So this is again something that cannot the CBOM provide as itself. You will need to have something more for that, where you can define the rules, where you can enforce policies on the keys and manage the life cycle to get to the point where you want to be. And lastly, you would like to monitor. So you would like to know what is the change during the time on your cryptographic assets. So you would like to put some real-time monitoring in place, or you would like to collect the CBOMs on the fly. And maybe you would like to analyze some historical data. So I will go quickly through the last slides, mention only the limitations of the CBOM. As you can see, the CBOM is typically static. So it requires some adoption because it was introduced only 6 months back. And it does not provide you key management capabilities. But using these considerations, the people will tend to build something like cryptographic proxy or crypto hub or similar kinds of components that will reduce the number of cryptographic libraries that are used inside the infrastructure and applications, because this will reduce the false positives. Maybe it will reduce some incompatibilities or compliance issues. And I believe that people will really start to use the CBOM as a standard for inventory of the cryptographic assets, because we need standards to be really interoperable between the systems and to achieve the cryptographic agility. I think this is really important prerequisite to be there. So from my perspective, having the CBOM is a really great start, but not the end. Example of the CBOM kit, I'm not going to talk about it. There will be a presentation later on about the tools. And that's it. You can create your own opinion about the CBOM, if it's enough or not. And as I said at the beginning, be careful when you are speaking about the CBOM on the public. And that's all I have. Thank you very much.
Thank you, Roman. We've been talking a lot about crypto agility. We just introduced a new term, presenter agility. We may have time for...
We do have a remote question, yeah. So this came in several slides ago. I believe it was the CBOM algorithm that you were showing on the slide deck. Would you know if the BOV on the slide would be comparable to a CVE scanner or a subset? with the Cyclone DX, are all functions available as total components or independent of each other?
I'm not 100% sure if I understand the question, but the CBOM provides the capability of having information that can be used by vulnerability scanners. It also contains the component which can include vulnerabilities. So from my perspective, this can be combined.
Okay, thanks for the talk. We experimented with the CBOM ourselves, and the question is, it's a syntax, but are there any efforts to like have some good practice how actually to build a crypto inventory? Because we had some problems to like how to interconnect the different algorithms and assets. I think there could be many ways to do this. Are you aware of this kind of stuff?
Yeah, this is, from my perspective, something that is currently missing. The CBOM can be used as a good baseline for this description of the inventory. As you said, it's a syntax, but not all components, all applications currently support CBOM. I believe there will be the higher adoption in the upcoming months. But it provides us a specific information about the specific component. So if we would like to build an inventory which we can manage, we can use for some analytics, then we will need to consolidate somehow all of these CBOMs, including some extensions that will help us to identify what we would like to do. And from my perspective, there will be a development, further evolution of the CBOM based on our experience, how we would like to work with the cryptographic inventory. And our goal is to create something that will be standardized, because we would like to achieve interoperability, to have a really good understanding how to work with the cryptography, which is currently missing.
Okay, thank you.
So thank you for the presentation. I would like to understand better how can we judge the completeness of the CBOM, because you ended the presentation with a question: is it sufficient or not? First of all, I haven't seen in the CBOM itself. I mean, you showed an example, but there I haven't seen the application where that particular algorithm is applied to. And the second point is, can I have a sort of automatic procedure to scan a complete system to understand where different cryptographic assets are resident?
Yeah, I was not presenting the complete structure of the CBOM. That was on the purpose, because it's a long one. But there is an information about the application, its version, including the hash, for example, so you can identify directly to which application the CBOM belongs to. And with the completeness, this is a bigger problem. How you can know that you have everything in your inventory? It's up to you to define the sources where you expect to have some cryptography assets and to create some automation. I was not speaking about the tools, also on purpose, because there will be another presentation later on, which will be presenting some tools that can also build the inventory and can use the CBOM. But with higher adoption of the CBOM, we will be able to consolidate all the information we are looking for, and eventually the inventory will be much more effective and more complete.
Thank you very much.
Thank you, Roman.